Hello and welcome students again in this class. This is lecture number 5 of this topic, acid, base and salt. So let's begin this class student without wasting our time, and let's move ahead on the next slide. Okay students, so here we are. Here we will talk about the bleaching powder. Just before the previous lecture, we saw that how bleach is formed, but this bleach is different from that bleach. That bleach was formed by sodium hydroxide and chlorine gas, but this is different. This is bleaching powder. So we will talk about first of all how is it formed. So guys, as you can see, the reaction is written here. We use this slaked dry lime and chlorine gas to produce this bleaching powder, and the formula of this bleaching powder is CaOCl2, and we also call it calcium oxychloride, because you can see there is calcium, oxygen and chlorine, so it is known as calcium oxychloride. Now guys, this is the reaction of the formation of bleaching powder. CaOH whole twice, this is dry slaked lime, dry slaked lime, and when you react this with chlorine gas, then it will form calcium oxychloride, and water will also form in this reaction. So I hope guys this basic reaction is clear to you. Now after understanding this, let's talk about the uses of this bleaching powder. So the first use of this bleaching powder to bleach cotton and linen in the textile industries. As you can understand by the name that it is bleaching powder, so it should be used to bleach the things. So it is used for bleaching. It is used for bleaching cotton and linen in textile industries. In textile industries. Okay. Now guys, what are the other uses? So the second use of this bleaching powder is bleaching wood pulp in the paper industries. Okay, so it is also used in paper industries. Paper industry. Okay, and the other use of this bleaching powder is disinfecting drinking water. So guys, this can be used as disinfectant because you can see that chlorine gas is also involved. Here chlorine gas is also present. So chlorine is used as disinfectant viruses. So that's why, because it contains chlorine as well, so this bleaching powder can also be used for disinfecting drinking water. Okay, so it is also used in drinking water for disinfecting it. Now guys, let's talk about the last use, and that is it can be used as oxidizing agent. Oxidizing agent. So you might think that how it can be used as oxidizing agent. So again, there is a presence of chlorine gas, and this is a non-metal, and non-metals are generally good oxidizing agent. So when I was teaching you chemical reaction and equation, that time I told you that oxidizing agent are the chemicals which oxidize the other chemicals. Okay, so non-metals are good oxidizing agent because they oxidize the other chemicals. I hope guys this thing is clear to you. Now if it is clear to you, so let's move ahead on the next slide and let's talk about the other salts which is to be studied. So you can also see this picture. This is the picture of bleaching powder. It looks like this. Okay, so now let's move ahead. So here we will talk about baking soda. Okay, this is also a daily use chemical which is used in our kitchen. So first of all we will see what is the chemical formula of baking soda. So NaHCO3 is the chemical formula of baking soda. Now we will talk about how this baking soda is produced. So guys, baking soda is produced on a large scale by treating cold and concentrated solution of sodium chloride, and sodium chloride is also known as brine, and we use this with ammonia and carbon dioxide, and when these four reactants react, then sodium bicarbonate NaOHCO3 and ammonium chloride is produced. So let me write down this equation. What we have taken? We have taken NaCl, which is a sodium chloride common salt, and water and carbon dioxide, and this NH3 which is ammonia. So when these react, then it will form an H4Cl, which is what? Which is ammonium chloride, plus NaHCO3, which is baking soda. Baking soda, and the chemical name for this NaHCO3 is sodium bicarbonate. Sodium bicarbonate. Okay, so I hope guys this basic thing is clear to you, that how we form this baking soda. Now guys, after understanding this, let's talk about the uses of this baking soda. So to understand the use, we have to know that when you heat this baking soda, then it will decompose in carbon dioxide, water and sodium bicarbonate. Okay, so let me write it here how this reaction takes place. Let's suppose this is NaHCO3. Okay, and when you decompose it or when you heat it, then it will break into an A2CO3, which is sodium carbonate, plus water and carbon dioxide. Okay, so guys, what we have seen, that carbon dioxide gas is released in this reaction. So when we understand the uses, so we have to keep this in our mind. Now this equation is not balanced, so let me balance this equation first. If I multiply here with 2, then this equation will become balanced. Okay, now guys, let's talk about the uses. So the first use of this, it is used as an antacid to treat acidity of the stomach. So basically guys, this NaHCO3 is a basic salt. This is a basic salt. This is basic in nature. If you are stuck in your home alone and you are suffering from acidity, then what you can simply do? You can simply consume this baking soda because this is basic in nature. Now guys, after understanding this use, let me write it here, this use, that it can be used as antacid. And we all know what is antacid. The antacid is the medicine which is used to cure acidity. Okay, now guys, let's talk about the second use. So the second use is, it is also used in the formation of baking powder. Let me write it here with another pen, baking powder. So lots of students get confused at this point. Here this is baking powder, not baking soda. Baking soda and baking powder are different. Okay, so how baking powder is formed? Basically baking powder is formed by baking soda when you mix baking soda with some edible acid. Okay, when you mix it with some edible acid, then baking powder is formed. So this is how we prepare baking powder. So baking soda is used in the formation of baking powder. Now guys, after understanding this, let's move ahead on the third point or the third use of this baking soda, and it is used in the preparation of cake and breads. Cake and breads. Okay, so this point is very important to be understood because guys, you might have seen that cakes and breads are very fluffy. So how do they become fluffy? So they become fluffy because of the baking soda. Let's suppose you have a batter of cake and breads and you have mixed baking soda inside it. So when you keep it on the pan and if you heat it, then what will happen? We know that when you heat sodium bicarbonate, which is our baking soda, that then carbon dioxide gas is evolved. So because carbon dioxide gas is evolved, so what will happen? This will make small pores in your cake and breads. Okay, so because of this small pores, it will become fluffy. So that is the reason why a cake and breads are fluffy, because of the evolution of carbon dioxide gas. So I hope guys these things might have been understood by you, that it is used as an antacid, it can cure your acidity, it is also used in baking powder, and it is also used in cake and breads to make it fluffy. Now guys, let's talk about the last use of this baking soda. So it can also be used in soda acid fire extinguishers. Let me write it here. Soda acid fire extinguisher. Okay, so guys, basically what will happen, let's suppose you are making a reaction between this NaHCO3 plus an acid, that is HCl. Okay, so guys, this is a metal carbonate and this is HCl, and that is acid. And we saw in this chapter only that when acid reacts with metal carbonate, then it forms a salt, and in this case the salt will be NaCl, water, and carbon dioxide gas is evolved in this case. Okay, Whenever metal carbonate reacts with an acid, it will form a salt, and water and carbon dioxide also evolve in this process. So guys, because carbon dioxide can be used in fire extinguisher, because it extinguishes the fire, okay, because it is heavier than fire, so it will break the contact between the fuel and the fire, so that's why it can be used in acid fire extinguisher or soda acid fire extinguisher. I hope guys this point is clear to you. Now after understanding this point, let's move ahead on the next slide and let's talk about the other important salt. Okay students, so here we will talk about washing soda, which is another type of salt. So first of all, let's see the chemical formula for this washing soda. So the chemical formula for washing soda is sodium carbonate. Sodium carbonate. Okay. And what is the chemical formula? This is Na2CO3 dot 10H2O. This is the chemical formula. Now guys, how do we prepare it? So in the previous slide, when I was teaching you about the sodium bicarbonate, which was baking soda, then I told you that when we heat this baking soda, then it will decompose into the Na2CO3 and water and carbon dioxide gas. You can see this equation that Na2CO3 and water and carbon dioxide gas is formed. So here also this reaction will take place and you can see that sodium carbonate is formed. Now guys, what can we do if this sodium carbonate is kept open in the air? Then it will absorb the moisture. It will absorb moisture around the air and it will become Na2CO3 dot 10H2O, and this is the actual formula for washing soda. Okay guys, I hope this thing is clear to you that how did we prepare this washing soda. Now after understanding the preparation of this, let's talk about the uses of this washing soda. So the first use of this, it is used in glass and paper industries. Glass and paper industry. It is widely used in glass and paper industries. Okay. Now what is the other use of this washing soda? So the next use of this washing soda, that it is used in the manufacturing of sodium compound. It is used in the manufacturing of sodium compound. Example of this is borax. Okay, this is a commercial sodium compound and we do not need to go in deep that what is borax, because it is not in the part of our syllabus. You can just understand that this is a sodium compound and this is formed by the help of this washing soda. Okay, I hope guys this thing is clear to you. Now let's talk about the very important use of this washing soda. So guys, it is used to remove the permanent hardness of water. To remove permanent hardness of water. Now guys, water are of two types: soft water and hard water. Okay, So basically soft water, you can use soap on the soft water, but on the hard water soap will not work, because there are the salts of calcium and magnesium in the hard water. Okay, so this stops the formation of bubbles, and you can also say this stops the formation of the foams. So that's why guys, what will happen, the soap will not work on hard water. So it is used to remove the permanent hardness of the water, like it can convert the hard water into the soft water, then we can easily use our soap. Okay, if I talk about the example of this hard water, then the sea water is an example of this hard water. Okay, it is very hard because of the presence of calcium and magnesium salt. So I hope guys this point is also clear to you. So yet we have seen three type of salt. The first salt we had seen in the previous lecture, and that was an ACl, sodium chloride, that was a common salt. And we had also seen the baking soda, that is sodium hydrogen carbonate. Here we have seen baking soda, and we also saw washing soda. Okay, and the other type of salt, and that is bleaching powder, calcium oxychloride. Okay, so yet we have seen four salts. First one was NaCl, second one was calcium oxychloride, third one was baking soda, and the other one was washing soda, that is an A2CO3 dot 10H2O. So after understanding these salt, let's talk about the other important points. So let's move on to the next slide. Okay students, so here we are. This is also very important salt, and that is plaster of Paris. Okay, so this is plaster of Paris, and the formula for plaster of Paris is calcium sulfate hemihydrate. Okay, how it is written? It is written like this: calcium sulfate dot half H2O. Okay, this is hemihydrate. Now guys, we will see that how this is possible. Basically guys, what happens, this one H2O molecule is divided into two calcium sulfate molecule, like this. Okay, so if two molecules are sharing one molecule, so one molecule is actually sharing half of the molecule. So that's why this is the formula of BOP. Now guys, let's talk about how do we get this BOP. So basically this plaster of Paris is prepared by heating gypsum at 373 Kelvin. Okay, so basically guys, this 373 Kelvin means 100 degrees centigrade. Okay, because we know if we want to convert centigrade into Kelvin, then we have to add 273 in this. So this will be Kelvin. Okay, so 100 degrees centigrade. Now guys, let's see that what is the formula for gypsum. So the formula for gypsum is calcium sulfate dot 2H2O. Okay, this is what? This is gypsum. Now when you heat this gypsum at 100 degrees centigrade, then it will form calcium sulfate dot half H2O. Okay, and 1.5 H2O or 1.5 molecule of water will be separated. So guys, this is how we prepare plaster of Paris. Now let's talk about the uses of plaster of Paris. So guys, this is used in statues. Okay, you might have seen lots of statues. These statues are form of POP. The other use also, this is also used in medical line. Basically guys, whenever we have fracture or we are suffering from fracture in our bones, then to settle down the bone we use this POP. Okay, because guys this POP has a quality that it becomes harder very quickly. It is a quick harder substance, because let's suppose this is your POP, this is in powder form, but as soon as you add water in it, it will become gypsum. It will become gypsum and it will become hard. So because of this quality we use it in settling down of bones. Now guys, let's talk about the other use, and that is it is also used in the fall ceilings. Okay, it is used in fall ceilings as well. So guys, I hope these uses of this POP is completely understood by you. So the chemicals we have seen yet are very important. Okay, first one we had seen an ACl. Okay, then we have seen calcium oxychloride, that is bleaching powder, and we also saw baking soda, that is NaHCO3. Okay, and then we saw sodium carbonate, and we also saw washing soda. Here on this slide you can see we also saw washing soda, and that is sodium carbonate dot 10H2O dot, let me erase it from here. Let me erase it from here. Okay, so this is a washing soda, and at last we also saw POP. So I hope guys whatever salt we had seen here have been understood by you. So let's move ahead on the next slide. So guys, here we are. Okay, so this is very important. We will talk about the types of solids. Okay, so basically guys, there are two type of solid. First one is amorphous and second one is crystalline. So what is the difference between an amorphous solid and crystalline solid? So guys, let me take you to the next slide, and here you can see that this is a example of crystalline solid, and this is amorphous solid. Okay, now guys, why is it amorphous and why this is crystalline? Because you can see that in crystalline solid there is a regular arrangement, or you can also call it a regular pattern between the ions and the molecules or the atoms in a solid. You can see that there is a fixed arrangement, but in amorphous solids there is no fixed arrangement like this. They are randomly arranged. So this is the difference between amorphous and crystalline solids. That crystalline solid have regular pattern, but amorphous solid does not have such regular pattern. These atoms or the ions are randomly arranged. Okay, now guys, let's talk about the example of crystalline and amorphous solid. So glass is an example of amorphous solid. Okay, this is an example of amorphous solid. On the other hand, diamond. Diamond is a great example of crystalline solid, and NaCl, which is common salt, sodium chloride. This is an example of crystalline solid because this is also have a regular pattern and the atoms are arranged in a regular shape. So I hope guys the difference between amorphous and crystalline solid is clear to you. So in amorphous solid, irregular pattern of ions, molecules or atoms. Example is glass. In crystalline solid, regular pattern of ions and molecules or atoms in a solid. Examples diamond and sodium chloride. So guys, after understanding the difference between amorphous and crystalline solid, let's move on to the next slide and let's see water of crystallization. We will talk about what is water of crystallization. So students, in the previous salts, we had seen, let's take an example of washing soda. So in washing soda, this is what? This is hydrated sodium carbonate. Okay, so there are 10 water molecule present in one formula unit of sodium carbonate. So this 10H2O is known as water of crystallization. Okay, so the same thing is written here that many salts contain water molecule and are known as hydrated salt. So this Na2CO3, this was anhydrous salt. This was what? This was anhydrous sodium carbonate. But when I add 10H2O in this, then it becomes hydrated sodium carbonate. This is what? Hydrated sodium carbonate. So this is water of crystallization. So the water molecule present in salt is known as water of crystallization. Now guys, one important point is to be known, and that is wherever there is the presence of water of crystallization, that chemical will become crystalline. Okay, that chemical will become crystalline. So let's take an example here so that you can easily understand what I am trying to say. I am taking blue vitriol as an example. So I am taking copper sulfate here dot 5H2O. Okay, so if I remove this 5H2O from copper sulfate, then this will become amorphous solid. But if there is a presence of 5H2O, that is water of crystallization, so it means this is crystalline solid. Crystalline solid. But here it is amorphous. Amorphous solid. And we already know what is the difference between crystalline and amorphous. So this blue, you can say powder, is basically hydrated copper sulfate. Hydrated copper sulfate because there is a presence of 5H2O. But here this 5H2O has removed. So this is anhydrous salt, or you can say this is anhydrous copper sulfate. Anhydrous copper sulfate because there is not presence of water, or you can say water of crystallization. So this is white powder, and when you hydrated it, then it will become CuSO4.5H2O, and the color also change, it becomes blue. Okay, so I hope guys these things are clear to you, water of crystallization. And now you might have also understood that why we were adding this water molecule in some chemicals, because this makes a chemical crystalline when water of crystallization is there. But some of the chemical are naturally present in crystal form. Okay, they are already crystalline solid, but some of the chemicals are not crystalline, they are amorphous, but when we hydrated it, then it will become crystalline. So I hope guys this is clear to you. Now after understanding this, let's move ahead on the next slide and let's talk about some of the examples. So guys, here we will see some examples. So the first example, you are able to see, write an equation to show the reaction between plaster of Paris and water. Okay, so guys, what is plaster of Paris? We all know that calcium sulfate of dot half H2O is plaster of Paris. So when this reacts with water, so this will convert into gypsum. We all know this, CaSO4 dot 2H2O. Okay, this is the formula for gypsum. Now guys, if we want to add 1 and half H2O here, then I will write 3 by 2 H2O. Okay, so this is the chemical equation for calcium sulfate dot hemihydrate, which is our POP, and water. Okay, now guys, let's talk about the second question. Classify the following into acid and basic oxide. So students, we all know that the metallic compounds are basic in nature and non-metallic compounds are acidic in nature. So MgO, where magnesium is metallic oxide, where magnesium is metal and MgO is metallic oxide. So this is basically basic in nature. Okay, and CO2, where carbon and oxygen are non-metal, and SO2, where sulfur is also non-metal. So these are acidic in nature. Okay, now let's talk about the third question. What is the change in pH values of milk when it changes into curd? Okay, so guys, basically we all know that when milk changes to curd, then there is a formation of lactic acid. So because it becomes acid, then the pH value will decrease. So here the pH value will decrease. Okay, so I hope guys these questions are clear to you. Now I'm ending this lecture and I will meet you in the upcoming lecture. Thank you so much guys and bye bye.